let's go ahead and start talking. Today we're going to be talking about operators and distributed workloads on Kubernetes. Seb is one of a kind. He is a senior software engineer at Elastic. For those of you that don't know him, he has spent most of his career working on distributed systems, building resilient applications, and orchestrating Apache Kafka and Elasticsearch nodes around the world. So it is my pleasure to introduce Sebastien, and just as a yay.
Can you do like a guitar riff or something? So
yeah, I can. It has been done before. I'll give you the big Sebastien.
Thank you.
And
thanks for
also
having
I've got here with me Bart, who is going to be helping us ask some questions. So I would love for everyone, this is a meetup there. You all are here. If you want to participate, if you want to ask some questions, feel free to leave them in the chat or the Q&A. I'll be monitoring both of those for you. And let's have some fun, man. Sebastien, before we get into anything, can you just let us know how you got into tech?
That's a good question. I think I was more or less always fascinated by tech since I was a kid. So at first, I really wanted to get into computer graphics. That's one thing. And then I sort of got bored about it in engineering school because it was all about vectors and matrix and complex computations. Interesting, but maybe not what I wanted to do in the first place. So I got more into distributed stuff, and at the time everything was about Hadoop, like all over. So I got really into it, and I think that's how it started. Like that's how I started working on distributed systems and things like that. But overall, anything related to computer is interesting to me anyway. So I guess that answers the question.
So you got the bug of the distributed systems, and I guess we can start there and dive a little bit deeper into it, because Elastic has been they've been around since 2010, I think. And what I'd love to hear from you is just how you've seen the world change over time, and how you've seen things shift towards Kubernetes and the role that Elastic is starting to play in Kubernetes.
Yeah, that's a great question. So obviously 10 years ago, Kubernetes didn't exist. And since that time, it changed a lot. And I think there's two aspects of it as far as Elastic is concerned. The first one is how Elastic integrated with Kubernetes so that people use the Elastic stack to actually monitor their Kubernetes clusters, for example. The second aspect is how over the time, we try to make it easy to run Elastic on Kubernetes directly, so that you use the Elastic stack to monitor your Kubernetes stuff, and you also deploy the Elastic stack itself within Kubernetes. So it's like this all-in-one thing that you can have. So the first part we worked on, like I think several years ago, on a product we have called Bits. Those are small agents that you deploy everywhere that gather logs, metrics, and stuff, and push them to your Elasticsearch cluster. And very early, we realized we need to integrate with Kubernetes because people want their Kubernetes metrics, Kubernetes logs, all in one place. That's one thing. The other part about deploying the Elastic stack on Kubernetes is a bit different. We started with Helm charts a few years ago. So there are official Helm charts for the Elastic stack. And after a few months, I think, we realized that we probably need more than that. Helm charts are fine, but we likely need an operator if we want to go beyond what we could do with Helm charts. So that's sort of the story of how Elastic and Kubernetes integrated with each other. Yeah.
And just to take that a little bit further, what are the differences between using Elastic for Kubernetes when we're talking about logging versus using for applications? What are the apps and what are the use cases there?
Yeah, so there are actually many use cases for Elasticsearch itself. I think a lot of people use use it for their infrastructure logs. So it's like this big platform where you can push all your logs and search them and build visualizations from that. But Elasticsearch is a lot more than that. It now also handles metrics very well. So you could use Elasticsearch in Kibana instead of using Prometheus, for example, or you can even send your Prometheus metrics to Elasticsearch. But people also use it for really the search engine feature. So you open Wikipedia, you search for something, and behind the scenes, that search goes through Elasticsearch and gives you a list of articles sorted by popularity and so on. So really, we have all those different use cases backed by the same stack, basically. So I think in the Kubernetes community, maybe the Elastic products are more common for observability purposes, but really there are a lot of people that use Elasticsearch for its powerful search engine features. There's a lot there, like synonyms, the ability to look for words that actually don't exist in a document, but the search engine would still return the document, even though the search query does not contain any words. It's about synonyms, like finding frequent words and this kind of stuff. It's super interesting. And I guess another use case I didn't mention is that a lot of people actually use Elasticsearch now as their primary database. So instead of putting data in a SQL database and maybe indexing some of those for fast queries into Elasticsearch, they just store things in Elasticsearch directly to start with.
So we can say that over time, it's expanded its capacity so that people don't have to maybe resort to other external kinds of tools, and they can do everything inside this sort of elastic environment.
Yeah, exactly. Yeah, exactly.
So, awesome. As far as operators go, and I know you're a storage ace, and we're going to get into talking about storage and Kubernetes in a little bit, but as far as operators go, I'm wondering, before we start talking about the nitty-gritty and get down and dirty with operators, do you foresee a world where operators aren't necessary on Kubernetes? Can you like envision that, or do you feel like now it's something that we need, we're always going to have, and this is the way forward?
It's a good question. I think one of the reasons why we need operators, at least currently, is that because there's a lot of application-specific knowledge you need to have to operate that application correctly. And it's not like there's a common standard across all the distributed applications, all the database. Like, they're not exactly managed the same ways. You don't make the same API calls to move data around. You don't make the same API calls to perform a backup and so on. So I guess if we wanted some sort of common solutions, we'd need to agree on a common pattern for everything here, which may happen in the future. But I guess it's hard because you could find some common features across all products, but there's always going to be edge cases and things you cannot fit in some sort of single generic management tool. So in the case of Kubernetes, for example, stateful sets are sort of an answer to having a generic way of deploying stateful workloads, but they're not exactly enough. They miss some features that they cannot possibly have because they would need to know like the real logic of how a product works in order to manage it the best way. So I think that's why we have operators on top of that. And I think in its scope, Kubernetes tries to stay generic so that it provides all the building blocks for whatever you want to do. But if you want to do more than that and something that's very specific, then I think Kubernetes can improve so that doing this specific thing becomes easier, but you'll probably always need some sort of custom logic there to do what you want. So I can hardly see a world where we don't have operators or something equivalent to operators anymore. However, I can see Kubernetes evolving towards less responsibility in the operators because most of the low-level stuff is already handled by Kubernetes itself. Or at least I hope that's the direction we're heading towards, because if Kubernetes starts like being strongly coupled to set of particular products, then I think we'll have a problem, because it means it suddenly has opinions on what people should be using.
Yeah. Well, and that, what you're talking about there is one of the other questions that I wanted to bring up around this idea of so many different operators and like a hierarchy of operators in a way. And have you seen, it's like you have all of these operators that are doing all of these different things, but which operators take precedence over what jobs? And have you seen that happen before, where it's just like there's so many different operators that you're using and each one is doing something, but then there's overlap and you need like a system of hierarchy?
Yeah, I did not see that problem a lot yet, but I suspect it's going to be happening at some point, because like even for a given product, yeah, if you take Elasticsearch, for example, there are already other operators out there, multiple operators that try to achieve the same thing, but not exactly in the right way. So if you deploy multiple, you might run into problems. But I think an interesting part is also how operators interact with each other, because if you take the Elastic operator, for example, we have simplified way so that Kibana, for example, can connect to Elasticsearch. So in the specification of Kibana, you would say, I want you to connect to the Elasticsearch cluster with this particular name. You don't have to specify all the configuration, like the TLS certificates, passwords, URL, and so on. But if you want to connect your own application to Elasticsearch, for example, your application is not part of the operator. So we could not possibly try to like facilitate or streamline that connection as easily, because we don't really own your application. It's up to you to configure it the right way. So I think here there's a sort of trade-off to find whether we want to have more control over what's outside the scope of a single operator. For example, what we could do is technically set up something called mutating webhooks in Kubernetes, so that if you create the pods of your application, we would dynamically mutate it to inject all the environment variables, for example, so that it connects to the applications managed by our operators. That's one example. But it's a bit disturbing, because it sort of reaches beyond the scope of what you would expect for that operator to happen. So you may then want to have multiple operators interacting with each other, which is possible, but it means if we want Elasticsearch to interact with Kafka, for example, it's like we have to pick the format of this interaction, and we have to pick one of the Kafka operators that we work with. And it's not like there's a common format everyone agreed on. So a simple thing is to rely on Kubernetes primitives, which is like the format everyone can agree on. Like if you communicate through sharing Kubernetes secrets, for example, you have to respect this secret format in Kubernetes. It works very well if you take the cert manager operator, for example. So this operator is managing TLS certificates. Like it can generate certificates for you. So I think it's up to other operators to ensure they are compatible with the generic certificate format of Kubernetes that cert manager also respects. So that's like implicitly both operators, like cert manager and the Elastic operator, for example, can interact with each other through this common Kubernetes format. And I think that's the hard trade-off, like relying on Kubernetes primitives with the format we agree on without having too much responsibility in the operators themselves.
Well, I remember when in our first meetup, we had Patrick McFadden on, Patrick McFadden or McFadden, I think. And he was talking about how for him, in his eyes, the Kubernetes primitives weren't built with data in mind. And so you run into a lot of problems when you start doing things with data on Kubernetes. And his whole thing was that the operators are great for now for what we're doing, but he foresees them, and he didn't like them as much because he felt like they were just building technical debt when you are basically tricking Kubernetes into thinking that it's doing something, but the operators are making Kubernetes think that, and then they go and they do their own thing on the side. And so I'm wondering if you also feel that way about, like, do operators create this technical debt, or is it only some?
Yeah, I think it's I think I agree with that in general. So the first thought was about how Kubernetes is not made to basically manage stateful workloads, which I think is true. Especially if you look at the early versions, there's almost no way you can run a database on Kubernetes because there's sort of this expectation that a pod can be recreated anywhere. Deployment can be scaled up and down. It's like very beautiful, right? Everything scales up and down and so on. But if you put data in the picture, then you screw it, because what do you do with your data? It suddenly disappeared. You lost it. Maybe that new pod doesn't have the old data available and so on. So it just doesn't work. However, I think the story changed a bit with stateful sets that were introduced in one of the early versions. And there's been a lot of work into that, I think, in slowly transforming Kubernetes and adding more new primitives over the simple pods so that we can really deal with data. And I think now it's really possible. I know some people would say using Kubernetes to deploy your database is a mistake. I think it's not anymore. I think this is really something you can do, and it works. And I know several companies who really do that in production, and it works fine. So I think it's slowly changing over time. However, the other part of what he said about how operators are basically take debt over what's missing in Kubernetes is also true, I think. I can give you a pretty good like technical example of something I just worked on like a few weeks ago.
Please do.
If you so say you want to deploy your database using a stateful set, so you do that, and suddenly you realize that you need to increase storage because the database is filling your storage. So instead of 100 gigs of storage per node, you need 200 gigs now. You cannot do that with stateful sets because it's immutable. You cannot resize storage in stateful sets. However, the lower level primitive, which is the persistent volume and persistent volume claim, allows you to resize the storage if the underlying volume driver supports it. So technically, you can resize Kubernetes volumes. It's just not possible when you manipulate stateful sets, which is sort of confusing. So what we did in ECK, the Elastic Operator, for example, is work around this limitation of the stateful sets and manipulate the lower level primitive directly, so that from the user point of view, they can still resize the volumes, even though we use stateful sets, because the operator like updates the underlying volumes directly, recreates the stateful set the right way, so it accounts for the resized volume, etc. But it may seem like a bit of a hack because eventually, we hope this is going to be implemented in Kubernetes, so we can sort of remove it from the responsibilities of the operator because it's becoming tech debt suddenly. So I think that's a very good example, but the downside is, in practice, it's not that easy because once Kubernetes implements this, it's not like we can suddenly remove all the code from the operator because people still run old versions of Kubernetes. If you take projects like OpenShift, for example, they have a very strict versioning scheme. For example, a lot of companies now still run OpenShift 3.11, which I think maps to Kubernetes. I don't remember which version, but it's a pretty old one now. So if you want your operator to be compatible with the use cases of most people, you have to be compatible with all those versions of Kubernetes. So you have to keep this tech debt around anyway for a long time because you still need to account for the missing feature in the old version. So in a way, what he says makes sense. But then saying it's only tech debt and it's bad is maybe a shortcut because they still provide like a very nice benefit over what you could do with Kubernetes alone, I think.
Since you mentioned stateful sets, how much does an operator need to abstract away from the user writing the full stateful set spec?
So the nice thing, I think, is you can really simplify what users can provide. Like, if you want to write a stateful set to deploy Elasticsearch, I bet the YAML file that you will write will be about 100 lines long, maybe, for the simple case. And the more you want to do, the more complicated it gets. If you want to associate to Elasticsearch clusters because you want to do cross-cluster search or cross-cluster replication, it's even more complicated, right? So what's nice with the operator pattern is that they come with this custom resource definition thing, and where instead of writing your 150 lines of YAML, you can write this small YAML file of only 5 lines maybe, and only focus on the important parts. And the operator will handle all the missing stuff directly because it knows exactly what's going to be the right stateful set spec. So that's one thing, like simplification. But the other thing is everything that needs to happen behind the scenes, where a single stateful set spec is not exactly enough to deploy your application. If you take Elasticsearch, you could write a single stateful set to deploy an Elasticsearch cluster, but in practice, if you run in a production environment, you want to split the Elasticsearch nodes into several groups. You want master nodes, data nodes, hot nodes, warm nodes, cold nodes with different configuration and performance characteristics, underlying hardware, etc. So a single stateful set is not enough. You need maybe 5 stateful sets. So suddenly you need to maintain some sort of synchronization between those stateful sets. And having the tools to help you do that is really helpful. and the other part is everything related to what I call day 2 operations. So it's one thing to deploy your stateful set and it works and it's great. Then in 2 months from now, you realize you need to resize the volume maybe, to use that example, or you need to change the configuration, or you need to upgrade the version. And suddenly you need more knowledge, because just changing the stateful set spec would maybe put the application at risk. There's always a risk that you handle this upgrade the wrong way, so you're losing availability across the nodes, your data is suddenly unavailable for a short while, or these sort of things. And that's what really an operator can do that the stateful set controller itself cannot.
All right.
Yeah, and so talking a little bit about building operators, I know that you gave a talk, what was it, last year at KubeCon, and for anybody that wants to check it out, I'll link to that in the chat right now and in the show notes. And you talked about the difficult parts of building operators, and I'm wondering if you could share with us a little bit about these potential pitfalls that can happen when you're going to build an operator.
Yeah, I think there are a few that come to mind immediately. The first one is, we talked about this abstraction where you have 5 lines of YAML instead of 300 lines of YAML. So that's all great. So you have this operator with this nice abstraction and people don't have to write a lot of YAML. But suddenly someone opens an issue in GitHub saying, I want to customize the label that gets applied on this particular pod, or maybe I want to customize the Kubernetes affinity settings, like deep down somewhere in this big stateful set YAML that gets generated. And it's hard because you did not account for that in your custom resource design simplification. It's so simple that there's no room for this really complex, tiny detail that people want to tweak in the Kubernetes resources themselves. So it's a bit hard to design the CRD, so the custom resource definition, in such a way that it's simple and sort of minimalist, but people that want to really tweak tiny details of the configuration can still do it. So one way is, I like to phrase it, if you build an operator, is that you have to provide good defaults, meaning the minimal version of it works fine and is great for many use cases, but you have to empower power users, meaning they can basically override whatever they can in the underlying resources that get generated. I think what we do in ECK, for example, is allow them to override the complete template of the pods that get generated. So if they want to tweak the environment variables of those pods, tweak the volumes, details, tweak the affinity settings, etc., they can still do it. So that's one thing about CRD design. Another important thing, I think, is that the design of Kubernetes in general is asynchronous. So basically, the general flow of things happening is that people send stuff to the API server. This is stored in etcd. And then behind the scenes, there are multiple controllers that grab whatever is in etcd and process it. And as part of this processing, they create other resources, do whatever is necessary, etc. But in this controller here, it's like you live in the past. You live, the resource you're processing is maybe out of date already, because at the same time, the user did update it. And it's a bit hard because each of those controllers work with a state of the world that is not exactly real time. It's slow, like slightly outdated. And it's even more true since they work with the cache of the resources in the API server. They don't do synchronous requests to read the information all the time for performance reasons. So there are cases where your controller does one thing, and a few seconds later it runs again, but maybe the state has not changed yet, or whatever operation you did before is not reflected yet in that second time you run things. So you end up like maybe undoing the things you just did before because your cache is not up to date. And this is super important to understand when you design an operator or a controller, that whatever you do needs to be idempotent, meaning you can repeat all the operations over and over and over again. It should not break things. And if you know about things that can break, you need to be extremely careful about that. If you manage databases such as Elasticsearch, for example, the Kubernetes state may say, I want 3 master nodes in my Elasticsearch cluster. In the controller, you realize that you have maybe a single Elasticsearch node running. So suddenly you decide you need to add 2 additional master nodes. So you do that, but now there are 3 realities, right? There's the reality from Kubernetes point of view. There's the reality from the operator point of view, which is slightly outdated from the Kubernetes one, but there's also the reality from the Elasticsearch point of view. So the operator needs to account for that, because otherwise it could be a mess. Like you could end up suddenly removing all your master nodes because you didn't realize that the ones you just added have actually been added to the Elasticsearch cluster yet. So like you think you recreate the same master node that you already created before, but maybe you're actually creating another one, and that could break Elasticsearch itself. So it's a bit hard to deal with, but it's also fascinating and super interesting. It's like the most interesting part, but also the harder to get right, because it can break everything if you get it wrong.
Yeah, and so many moving parts.
Yeah, exactly. And it's also true for Kubernetes itself. If you look at the Kubernetes code base, you'll see that they have tricks around that. Like, for example, to prevent the deployment controller from creating too many pods, because it's running a second time and it didn't realize that the last time it already created the pods it's supposed to. So to avoid like creating them again, it's keeping some state in memory that says, I have created those already. It's called expectations. So you don't need to create them again until you see in Kubernetes state that, yes, they have actually been created, so you can move forward. So it's a bit tricky. Yeah.
So as far as just bouncing around a little bit, like as far as the percentage of users that you've been seeing, if you know this, maybe you don't have any idea, that are using Elastic with Kubernetes, do you have any insight around that? Is it becoming a standard that you're seeing?
It's a bit hard to answer. It's definitely getting more and more popular, judging by the number of issues on GitHub and questions we have, and also the number of like large companies that actually rely on the Elastic operator. So it's progressing. I don't know the exact ratio over like the entire user base not using Kubernetes, it's a bit hard to say, because there's a like sort of a second shift happening at the same time, is that people realize that it's the best thing to do is maybe to rely on Elasticsearch SaaS service. So they would use Elastic Cloud directly and not manage their Elasticsearch clusters themselves, because it's much easier, it gives more features, etc. So it's like these two things happen at the same time. People have Kubernetes deployed at the company, so they start using it more and more. At the same time, they also rely more and more on SaaS services, because they realize that maybe it doesn't make sense to pay 15 engineers to manage all these things internally.
Yeah, I totally understand that. That's a smart move.
Now, earlier you were mentioning, best practices are things to keep in mind to avoid problems with operators. But what are some of the best practices around using Elastic within Kubernetes? I mean, should Elastic be configured to take care of high availability, or should that be delegated to underlying storages?
That's a great question. That's a question I still ask myself sometimes. So traditionally, all those distributed systems sort of work based on the fact that they handle replication of the data and they handle availability themselves. In part, that's because when they were created, like advanced orchestration systems such as Kubernetes did not exist yet. The situation is a bit different now, because if you rely on persistent volumes in Kubernetes, for example, storage is sort of already replicated for you. So if a disk fails, the underlying system already handles that. You don't even see it as a user. So you could say, I don't even need to replicate my data at my database level, because the underlying storage already does that for me. But I think it's not only about the risk of losing the data. The fact you need to replicate also has to deal with performance. If you want to read your data very fast, you may want to query it through multiple nodes at the same time. So maybe all those nodes need the same copy of the data. So it's not only about like really risking to lose the data, but also about this availability and performance problem. The disk can fail, but the actual server can also fail entirely. So even though you can remount the disk on another server, there's still like maybe 1 minute of transition where you need the new server to start, etc. So you still lose availability here. So I think, at least so far, it still makes sense for the workloads and, for example, Elasticsearch and all the databases to handle replication themselves and not rely that much on the underlying storage systems. Because there are also a lot of differences across all the storage systems you can get. If people believe they can just rely on the storage replication system, but in their on-prem Kubernetes cluster, they don't have AWS EBS, they have maybe their NFS shared volumes with super bad performance, for example, that's not going to make it. So I think there's real benefit in really having the workload handle replication and availability on top of Kubernetes itself. And
let's dive into like local volumes a little more, because I know you spoke about that earlier, and I saw that on GitHub, the Elastic, Elastic recommends that you use like OpenEBS or Topo LVMs for providing storage. And I'm wondering, like, can you describe a little more on why local storage is preferred?
So you did your homework. Deep dive into Elastic GitHub repositories. That's nice. So this local volume project is now sort of archived, but it was an early prototype of a local volume provisioner for Kubernetes, because this is still very immature in Kubernetes itself, local volumes. The nice thing is you can extend Kubernetes pretty easily, so that's how we suddenly see more and more projects around storage coming up everywhere. And Topo LVM and OpenEBS are two really great examples of things you can add to Kubernetes to handle local storage because Kubernetes itself does not do a great job at it. So we did a few benchmarks at Elastic because there's this question. Historically, we encourage people to always use local disks for their Elasticsearch workloads because people otherwise would complain about bad performance if they use network attached storage. To repeat that again, people that use NFS storage, for example, to back Elasticsearch, that's usually pretty bad.
Everybody,
okay
so many people come on here and they just hate on NFS so much.
Yeah, probably. Yeah, I guess that's because they have to deal with these large setups where the only storage system is NFS, maybe. But it's improving real fast. If you look at just AWS or GCP, for example, their network attached solutions are getting faster and faster. On AWS, there's the IO1 volumes and GP2 volumes that are already pretty good. So you actually get pretty decent performance. In some of our benchmarks, we realized that in some use cases, you get almost the same performance when using network attached volumes than when you use local volumes, which is super nice because if you use network attached volumes, operations are much simpler. You can lose a pod, recreate it somewhere else, reuse that same volume. It's all super easy and made super easy by Kubernetes. Whereas if you use local volumes, it's a bit more tricky because if you lose a node, the new pod can be created elsewhere, but there's a constraint that it needs to be created where the volume lives, and the volume lives on the node that failed. So it's like you need to manually acknowledge that you lost this data, lost that pod. So you would manually remove the pod and the volume so that it can be recreated with an empty volume, but it's a bit more involved. Local volumes are more complicated, but at the same time, that's what gives you still the best performance. I think, of course, if you have like locally attached NVMe SSD disks, that's always going to be faster than using the network to store the data. I think if you take Elasticsearch, for example, it really depends on the use case. So if the workload is heavy on the writes, meaning you index a lot of data into Elasticsearch, the bottleneck might actually be CPU and not storage. So like if you do your own benchmark, you should make sure you're not bottlenecked by the CPU if you try to compare the storage, because the numbers won't make sense. But if you do a lot of reads, then the latency to access the data on the disk is usually much better when the disk is local. So on search-heavy use cases, we realized that we get like maybe 50% or 70% improvements by using local volumes instead of network attached volumes. So the overhead in operations is actually worth it if you want the additional performance.
All right. To kind of continue on with that, just because earlier we were talking about Elastic specifically on Kubernetes, we got a question from the audience. Matt Seymour, first of all, thanks for the question. Getting into some sort of transparency with Elastic, what should be the criteria of moving hosted Elastic solutions to a Kubernetes Elastic solution? Are there cases where Elasticsearch in Kubernetes is not a good choice?
So when you say hosted Elastic solutions, I guess you mean, for example, an Elasticsearch cluster that you don't manage yourself, but that is hosted somewhere on an online service? Or do you mean like self-hosted, like in your own servers?
Managed,
yeah. Okay.
Managed, yeah.
So in general, like the managed service will always be simpler and better. If you take Elastic Cloud, for example, it's you don't have to care about anything. There's just a simple API. You say, I want that many nodes, and we handle everything for you. The cloud team at Elastic handles everything for you. Whatever failure there are, etc., you don't have to deal with it. So it's always going to be simpler. I think with the operators, it's getting easier to manage your Elasticsearch workload on your own Kubernetes cluster, but it's not entirely free. There's still like, you still need to know your way around Kubernetes, how to manage Kubernetes volumes yourself, how to deal with Kubernetes upgrades, which are an entire beast to tackle. So yeah, the nice thing is it's simpler because the operator does part of the job, but the downside is suddenly you also have to manage Kubernetes. You need to understand a little bit of how the operator works with your Kubernetes cluster. So you don't only need to know about Elasticsearch, you also need to know about Kubernetes, whereas the hosted offering is going to be much easier for that.
So bouncing around like a ping pong ball, I'm going to hit you with one that's a little bit back to what we were talking about on this idea of local storage. And for you, like, do you feel like there's any limitations with stateful sets and how they're implemented on Kubernetes?
Yeah, so there's this big limitation, especially on resizing the volumes that I touched on earlier. That's a sort of big missing feature currently, but you can work around that. So that's one thing. The other thing is generally Kubernetes is working with the assumption that the volume is available whatever host the workload is running on. So basically, the assumption is that you use network attached volumes. If you use local storage, the story is a bit different. There are cases where what could happen is that a pod gets scheduled on a node and the volume gets scheduled on a different node. So it cannot possibly work because the data is not available where the pod runs. It's just impossible. The Kubernetes team introduced ways around that. And you can, for example, configure your storage class that represents your storage system to say, I want my volume to be scheduled only once the pod itself has been scheduled. So the volume now has a constraint to live on the same node as the pod. That's what they call the volume binding mode in this storage class thing. But it's something they added later on. So it's like an additional thing you need to configure. And it's a bit funny because if you spin up a cluster on GCP, for example, a GKE cluster, you may have to manually add this setting yourself to not run into this situation where you have the volume in the pod in different places. So that's one good example. And everything around local storage is not completely figured out yet. That's sort of my conclusion on that. If you deploy pods on a Kubernetes node, you know that the pod can only possibly be deployed on a node that has enough CPU and RAM for the pod to live there. It's part of the specification of the pod of the node, and the Kubernetes scheduler accounts for that. But it doesn't consider storage. So you could have a pod that gets allocated on a node, and if the local volumes are dynamically provisioned, meaning they don't exist, they are created on the fly when a pod requests it, it's possible that on that particular node, it's not possible because there's not enough storage, but the Kubernetes pod scheduler doesn't care because it only cares about CPU and RAM, basically. So it's work in progress. I think the next version of Kubernetes improves that already to account for storage capacity and scheduling. But because of that, people have to work around it again. If we take Topo LVM that we mentioned earlier, that is, I think, a really great local storage provisioner. They implemented their own plugin to the Kubernetes scheduler so that it accounts for storage, for example. So that's another sort of example of introducing something else with additional tech depth because you want to work around something that is not there in Kubernetes yet.
Well, and at the risk of beating a dead horse, I just wanted to ask about how you feel like operators should deal with this storage, and especially around like the price to performance trade-off.
Yeah. I think the best thing operators can do, and the thing they should do, is be generic enough so they can be compatible with any storage provider. It's nice that Kubernetes has this persistent volume abstraction because basically operators only need to care about persistent volumes. And then how those persistent volumes are then mapped to the physical storage is decoupled from the operator responsibility, which is great because then you can install whatever storage provider you want, completely decoupled from the operator itself, and it will work the same way. You can even entirely replace your storage backend, and there's no configuration change in the operator itself. So that's nice. But still, you have to make the right choices on the storage system you choose, because there's this performance hit that we touched on earlier, like whether you use local storage, network attached storage, etc. It's not only performance. Performance is a pretty important criteria, but the price is also important, because obviously if you use network attached storage, you will pay with a different pricing model than when you use locally attached SSDs. Like, instead of paying for the number of seconds where the disk is attached to your server, you would pay for the number of I/O operations you do per second, and the latency of those operations, and how much you can do in a given month, for example. So like, you could use your entire quota for several hours, and then you cannot do I/Os anymore. So the pricing model is really different. And to be compared, for the comparison to be fair, you need to like sort of integrate the pricing when you choose this storage backend. So I think it's nice that this responsibility of choosing the storage is left to the users, and the operator itself just works with whatever gets provided. But then we need to make sure we sort of educate people so that they don't make bad choices related to storage, because otherwise you could believe it's the operator fault if the performance is bad, but really it's because of the underlying storage.
Awesome. Thank you. I've been writing to Demetrius back and forth in our chat because I really wanted to get to this question. Watching the Elastic meetup that you participate in on October 2nd, it almost gets to the point that something you did was so well crafted that I hope that the people at Elastic and the marketing department will take advantage of this. But you made a great comparison to Baby Yoda. All right, using I'm gonna put this in the chat right here just so everyone can see.
He was so excited. Can I just say how excited he was to ask this question?
This afternoon. So anyway, I'll put it here. It's quite poetic, but I think it's really nice, because we're talking about stuff that's really complex, and sometimes it's difficult to kind of get things on the ground and more tangible concepts. So your use of Baby Yoda as a way to kind of introduce language that's really accessible and easy to understand. I'm just going to put this in here, and then you can kind of comment on it. All right. So on my Kubernetes cluster, the Elastic Stack I want to run, but many challenges I have to face. Safe is my data, available is my cluster. Like I said, for a guy who's writing this as well too, not in his first language, very impressive. I hope there are lots of memes and tweets that go on about this. But if you could just comment a little bit about how you got to that point, and what it says about your experience, working with Kubernetes for a while, all the different things that you've seen going on. How did you get to that, and what does it say?
Yeah, so first, Elastic is completely unrelated to Baby Yoda in general. We don't get free Disney Plus subscriptions whenever we mention
copyright
Baby Yoda.
Infringement. None of that.
Mostly that was a way for me, that's what I said before, it was a way for me to make sure I keep people's attention during the presentation. Like, things are boring, suddenly you introduce a GIF of Baby Yoda, and everyone's looking at you again. So yeah, so about that code, the first one, on my Kubernetes cluster, the Elastic Stack I want to run, but many challenges I have to face. That's because it's sort of a natural fit that people get Kubernetes deployed a lot more than before. And suddenly they want to run everything on Kubernetes because that's what they have. And maybe their IT head decided that Kubernetes is the way to go. So suddenly everything needs to go into Kubernetes. So people are now trying to understand how to fit complicated things with their Kubernetes clusters. It's simple when it's stateless, but it's a lot more complicated when it's stateful. So if you want to deploy Elasticsearch, for example, you need to have some sort of understanding of how Elasticsearch works to run it correctly on Kubernetes. And it's not because you can come up with the right YAML stuff initially and that it runs, that you can run this in production for years. Because, as we said, you need to deal with upgrades, version upgrades, scaling up, scaling down the cluster, etc. So that's what are the challenges in this sentence. you think Kubernetes and Elastic is the right fit, and actually it is, but it's slightly more complicated than that. You need to understand things. So that's why you likely need an operator, because the operator does the job for you, basically. And then the second part, safe is my data, available is my cluster, is sort of the contract that the operator must respect. Whatever it does, that's the job. Make sure the data is safe and the cluster is available. Whatever operation it has to do, like removing nodes, adding nodes, rolling upgrades, moving data around, etc. It always has to care about this big invariant in the system that is, you don't break the availability, people can still use the cluster whatever you do, and the data itself safe. And it's not only the data that you send that needs to be persisted, but also all the metadata flowing around the system. So because it's a distributed system, there's this concept of having a leader and a quorum, etc. And so you need to make sure you don't break the consistency of the system here. So that's another like huge part of the responsibility of the operator. So overall, the sentence is like, you want to run Elastic on Kubernetes, fine, it works. You need to know a little bit more if you want to do the right thing, and that's why the operator is probably the best thing to deploy for you.
So along those lines of this idea, like, oh yeah, we're going to use Kubernetes and let's run everything that we're used to running on our Kubernetes cluster. I had a question from a friend, Paul, and he was talking about, I think I can't remember when it was, but Target, I think, is the one who had a problem because they were using Kafka and they had a dependency with Kafka. It was like there was this single point of failure because everything was running through this message bus. And so I'm wondering if you know ways to make sure that you don't get a single point of failure if you start using Elastic and then you start using it for more and more stuff and it becomes a bit of a dependency.
Yeah, it's a great question because I think Kafka, for example, was sort of created because people tend to have this gigantic mess of components in their architecture. So like they have the application that talks with several databases, other stuff running around that also talks with several databases. They realize they need to replicate data from one place to the other. So that's another replication service that needs to do that. And if you look at the architecture of that project, it's like a complete mess. It's hard to make sense of it because there are so many moving parts around and data is flowing everywhere. So the nice thing about Kafka is that you send data in and then you have this message bus and everything can read from it. So it's like the central backbone of your data flowing around in the system. But of course, as you said, it becomes the single point of failure now, because if Kafka dies, you lose everything. In a way, that's sort of also true with Elasticsearch. If Elasticsearch is your single data store and everything interacts with Elasticsearch, if Elasticsearch fails, then you lose access to the data, basically. So we try to make sure the system is distributed, handles replication and availability because it's composed of several nodes. So if one dies, the rest of the system can be resilient to that failure. But that's also true for Kafka. So I guess the most important thing to do is make sure that the central storage system is operated correctly. So it does not fail in the first place, or at least so that you minimize the impact of the failure. But now there are still ways to deal with that. With Elasticsearch, for example, on the Elastic Stack, you can set up cross-cluster search and cross-cluster replication features, meaning there's this central cluster where maybe most of the things are happening, but you can replicate the data from that cluster A to a cluster B in like near real time. So if cluster A fails, you could like suddenly just redirect the flow of requests to that second cluster B, because you had that first replication level within a single cluster that cares about the failure of individual nodes, but then you also have the second level of replication that cares about the failure of an entire cluster. So I think that's one important thing that you do. The other thing is when you send data to Elasticsearch, what we generally advise to people is that they have these small agents they deploy everywhere. In the Elastic Stack, there's this product called Bits. Small agents you deploy on each individual server, for example, and that's the one thing that is sending data to Elasticsearch. So having one of those agents that fails is maybe not a big deal because you have all those hundreds of agents deployed everywhere. So the data keeps flowing around, and you can fix this particular one that is failing. It's not going to break everything. Whereas if you introduce another layer in front of Elasticsearch, for example, so like you would have data sent to maybe a message bus, and then you would then send the data to Elasticsearch. Is a bit more dangerous because you introduce another part that can fail in the same system. So now you need to make sure you can handle the failures of that new component the right way. I'm not saying this is not the right thing to do, by the way. Using Kafka to act as a buffer for things that get sent to Elasticsearch is generally a good thing to do, but it's all about knowing where things can fail and how you can react on that. It's like sort of the same story as the backup. It's nice to know that you have a backup story, but if you don't experience it and make sure that it works, then things can fail and you won't be able to fix it.
Yeah, knowing where your vulnerabilities are, just in case.
Yeah, exactly. Yeah. I bet Baby Yoda knows that.
Yoda's smart enough for that. Even when he was a baby, he knew that. So, man, this is awesome. Thank you so much for coming and talking to us. Everyone that is still here with us, if you want to join us in Slack and talk more about operators, we've got our own Slack workspace. I'm throwing it in the chat right now. Come say hi. Seb is in there sharing his wisdom with us. We've got a lot of other smart people. Most of the other folks that I've gotten on here and have shared their wisdom with us, they're all in Slack. And so come ask us questions. We're trying to, the whole goal of this community and this Slack workspace is to advance the data on Kubernetes space so that it becomes less of a headache. I think one thing is very apparent as we talk to you, Seb, is that yes, as Baby Yoda says, I want to run my Kubernetes cluster, but many challenges I must face, right? So this is what's going on, and especially when it comes to data. And so we're trying to just have conversations around it and make it easier. There's all these experts that are there. So feel free to jump in the Slack workspace and join us. And thank you, Sebastien, so much for sharing your wisdom with us. This has been a super insightful conversation. It was really easy talking to you, and you've said a lot of very interesting things.
Sure. Thanks for having me. It was super nice. See you next time, I guess.
Yeah, exactly. We'll come back for round two. Operators round two.
Definitely got a round two. Definitely got to play that.
All right.
Thanks a million, man. All right.
Thanks.
Take care.
See y'all.
Bye.